Hey everyone, buckle up because today we're diving headfirst into the mind-blowing world of quantum computing.
Sounds exciting.
It is, and we're zeroing in on Microsoft's latest work.
Mhm.
They just dropped this new chip that's built on a totally different idea than what everyone else is doing.
Yeah, their approach is pretty revolutionary. It could really shake things up in the quantum computing world.
Totally. But before we get ahead of ourselves, let's break it down for anyone who might not be totally familiar with quantum computing. What is it exactly?
Think about it like this. Our everyday computers, they use bits, right? Like a light switch. It's either on or off.
Right, ones and zeros. Got it.
Exactly. But quantum computers, they use qubits, which are way more bizarre. It's like a dimmer switch. They can be on, off, or somewhere in between all at the same time.
Whoa, okay, that's a little mind-bending.
Yeah, it gets pretty wild. And because of that, they can tackle problems that would take our regular computers, like, forever.
Okay, so that's quantum computing in a nutshell. But what's so special about what Microsoft is doing?
So Microsoft is using these things called Majorana particles to build their qubits, and they're calling it the Majorana 1 chip.
Majorana particles. Okay, you're going to have to explain that one.
All right, so these particles are super weird, even for the quantum world. They're their own antiparticles, which basically means they have this inherent stability that other types of qubits just don't have.
So they're like the rock stars of the quantum world.
Kinda. And traditional qubits, they're super fragile, prone to errors. But Microsoft thinks these Majorana particles are the key to making quantum computers way more reliable.
I see. So it's all about building a more stable foundation.
Precisely. It's like constructing a house on solid bedrock instead of shifting sand.
Okay, that's a great analogy. But what does all this mean in the grand scheme of things? What kind of impact could this have on, well, everything?
Okay, so imagine a world with quantum computers that have 1 million qubits or even more. That's the kind of processing power that could revolutionize everything. We're talking designing completely new materials, breaking down pollutants like it's nothing, even developing personalized medicine tailored to your DNA.
1 million qubits. That's mind-blowing. It sounds like we're talking about a whole new technological revolution.
We are, and Microsoft might just be leading the charge with this new approach. It could be a giant leap toward making quantum computing something we actually use every day.
That's incredible. But I'm sure there's still some pretty big challenges, right?
Oh, absolutely. Scaling up to 1 million qubits, that's a huge engineering feat. And there are still hurdles to overcome with error correction, basically making sure these computers don't make mistakes.
So it's a race against time and a race against, well, the complexities of quantum mechanics itself.
Exactly. But the potential rewards are so huge that it's a race worth running.
It's all incredibly exciting, but before we get lost in the future, let's take a minute to acknowledge the present. This deep dive is brought to you by Stonefly, a company that's helping businesses navigate the increasingly complex world of data.
Right. They offer solutions for data storage, backups, disaster recovery, all that good stuff. They're all about making sure your data is safe and sound.
And, thinking about the sheer amount of data quantum computers will generate, companies like Stonefly are going to be more important than ever.
Absolutely. As we move into this new era of quantum computing, having a solid and secure data infrastructure is going to be mission critical.
So a huge thank you to Stonefly for supporting this episode and helping us explore this wild world of quantum computing. Now let's get back to Microsoft and their groundbreaking work. We were just talking about the potential of a 1 million qubit quantum computer. Could you paint a clearer picture of what that would look like? What kinds of problems could we actually solve with that kind of power?
Welcome back, everyone.
It's awesome to be back. We're in the thick of it now with Microsoft and their quantum adventure. Last we left off, we were talking about how they're using those Majorana particles. That's got to be one of the most interesting parts of all this.
It really is. And the whole thing comes down to how those particles behave. See, they've got this unique property where they're their own antiparticle, which is super rare. That makes them ridiculously stable compared to the other qubits out there.
Yeah, you mentioned stability is like the holy grail of quantum computing. But I'm still not quite wrapping my head around how these Majorana particles actually work.
Okay, so picture a wire, but like super tiny, only a few atoms wide.
Whoa, that's tiny.
Right. It's called a nanowire. Microsoft is making these special nanowires where they can actually get Majorana particles to exist on either end of the wire.
Okay, so now we've got these itty-bitty wires with these even weirder particles hanging out at the ends. How does that turn into a qubit, the thing that actually does the computing?
Good question. It's not actually the particles themselves that act as the qubit. It's more like the relationship between the two, like how they're linked together. That's where the quantum information gets stored.
So it's like they're connected by this invisible thread or something.
Yeah, that's a good way to think about it. And this connection is super strong, like really resistant to anything trying to mess with it. That's where the stability comes in.
So even if there's like noise or interference from the outside world, those two Majorana particles, their connection stays strong, and that protects the information.
You got it. It's like having a safe that's totally uncrackable because the combo is baked into how the parts of the safe are connected.
Man, that's a really cool way to think about it. So how do they actually control these Majorana qubits? How do they tell them to do calculations and stuff?
Well, they actually use microwaves, like similar to your microwave at home, but way more precise and controlled.
Microwaves. Seriously.
Yep. By hitting these nanowires with specific microwave pulses, they can tweak the connection between those Majorana particles. And that's how they do the quantum operations, essentially.
So it's like they're using microwaves to make these particles dance, and their moves are what actually process the information.
That's a pretty poetic way to put it. But yeah, you're right. And because the information is encoded in that super strong connection, it's a lot harder for errors to creep in, even when they're manipulating things.
This is wild. It's incredibly complex, but so elegant at the same time. But let's zoom out a bit. Connect this back to the bigger picture. We've talked about quantum computers being able to solve problems that regular computers just can't. What are some examples of those problems?
Okay, so one of the areas where this has the most potential is drug discovery. Imagine being able to simulate how molecules interact, like at the atomic level. That would let us design drugs with insane precision. We're talking targeting diseases in a way that's just not possible now, with minimal side effects.
That's amazing. We could finally cure diseases that are impossible to treat now.
Right. Another big one is materials science. Quantum computers could let us create materials that we can only dream of today. Stronger, lighter, way more durable and efficient. We're talking about materials that could repair themselves, or superconductors that can transmit electricity without losing any energy at all.
Wow. That would completely change everything, from how we build buildings to how we get our energy. It's crazy to think about.
Yeah, it is. And don't forget about optimization problems. Things like figuring out the best way to get around a city, or how to make supply chains super efficient. Even finding ways to fight climate change more effectively. Quantum computers could help us figure all that out, too.
It's mind-blowing to think about just how many possibilities there are. But I also can't help but wonder about the challenges of building a million-qubit quantum computer.
Huh.
What are the biggest hurdles they still have to overcome?
Well, even though these Majorana qubits are naturally more stable, you still got to be able to control them on a massive scale and make sure they don't make mistakes. Imagine you're trying to control 1 million dancers, all doing the same routine perfectly in sync. Any tiny misstep could throw everything off.
Oh, I get it. It's like a massive choreography project. So being able to control all of that is one of the biggest challenges.
For sure. And then there's the problem of actually making these chips. We're talking about manipulating atoms. That takes some seriously advanced technology, and we have to make sure it's consistent.
And we can't forget about the software, right? We need programs that can actually understand and use the power of these quantum computers.
Exactly. We need a whole new way of thinking about how to write code to solve problems in this quantum world.
It seems like there's a lot of work left to do, but the potential is just so amazing. I'm really glad people are working on this.
Me too. And it's important to remember that Microsoft isn't the only one in the race. There are other companies trying different approaches, and all that competition is pushing things forward faster.
It's like a worldwide brain trust, all working together to figure out quantum computing.
Totally. And just like when we invented the regular computer, this could change our world in ways we can't even imagine right now, maybe even more.
It's incredible to think about. And as we move into this new world, it's really important to remember data security. That's why it's so awesome that companies like Stonefly are working to make sure data management is secure in this quantum age.
Totally agree. Stonefly is doing some really important work with backups, disaster recovery, and cybersecurity. All that is essential to make sure that businesses can keep their data safe no matter what happens.
It's good to know there are companies like Stonefly on the front lines, keeping our data safe as we go into this unknown territory. Now, back to the potential impact of quantum computing. We've touched on drug discovery, new materials, and solving crazy optimization problems. But are there other areas where this tech could be a game changer? And we're back for the final stretch of our quantum journey.
It's been quite a ride exploring Microsoft's work, hasn't it?
Absolutely, from those wild Majorana particles to the dream of a million-qubit computer. But I gotta ask, What other areas besides material science and drug discovery could be transformed by quantum computing?
Well, one that really gets me thinking is artificial intelligence. Quantum computers could give AI a massive power boost, letting it solve problems that are just way too complex right now. Like imagine AI that can model the human brain or even the entire planet's climate with incredible detail.
Whoa, that's huge. We could have AI helping us tackle some of humanity's biggest problems. But I gotta admit, that also makes me a little nervous. I mean, AI is already incredibly powerful, so what happens when we give it a quantum upgrade?
I hear you. We definitely need to tread carefully and make sure we develop AI in a responsible way. It's about making sure AI works for us, not against us.
Right, it's a powerful tool, and we need to use it wisely. It feels like we're entering a whole new territory, and we need to be aware of the potential consequences.
Absolutely. Another area where quantum computing could really shake things up is cryptography. Most of our online security relies on encryption algorithms that are tough for even the best computers today to crack. But with enough power, a quantum computer could blow right through them.
So everything from our bank accounts to top secret government data could be at risk.
Potentially, yeah. That's why researchers are already working on new kinds of cryptography that are quantum resistant, basically staying one step ahead. It's a constant race to keep our data safe as technology keeps evolving.
It sounds like a high-stakes game of cat and mouse between the good guys and the bad guys.
In a way, yeah. But the key is staying aware and being prepared. We got to be ready for the challenges that come with quantum computing while also being excited about all the good it can do.
It's about balancing innovation with responsibility.
Exactly. We need to be bold in our pursuit of scientific advancements, but also think carefully about the ethical implications and what could go wrong.
And speaking of responsibility, I'm reminded of the work that companies like Stonefly are doing in this new era of quantum computing. They're the ones working behind the scenes to ensure that our data stays safe and accessible no matter what challenges we face.
Couldn't agree more. Stonefly is doing some crucial work with their data storage, backups, and disaster recovery solutions. They're all about building a secure and reliable digital world.
It's reassuring to know that companies like Stonefly are out there working to keep our data safe as we enter this unknown territory. Well, as we wrap up this deep dive, I'm filled with a sense of awe and anticipation. Quantum computing is truly a game changer, and it feels like we're just beginning to grasp its potential.
I'm with you on that. It's a field brimming with challenges and opportunities, and as we go forward, we need to keep having these conversations about the ethical side of things and how this tech will impact society.
We need to make sure that everyone benefits from quantum computing, not just a select few.
Exactly. It's our collective responsibility to shape how this technology evolves and ensure it's used to make the world a better place.
That's a perfect note to end on. Big thanks to Stonefly for supporting this deep dive into the fascinating world of quantum computing. And to all of you listening, thank you for joining us on this adventure. We hope you've learned something new and are as excited as we are about the possibilities ahead.
Remember, the future doesn't just happen, it's something we build together.
So let's build a future where quantum computing empowers us to solve our biggest challenges and create a better world for everyone.